Okay, part B. Point minus 1, minus 2, 0 lies on the road. And essentially, when you get to W from C, find the shortest length. The shortest length is always perpendicular, so we have to find the point on the pipe that is perpendicular to that point on the road when they're joined up with the pipe. So first we need to find the point on the pipe. So we know from the first part that the water pipe, let's call it W. The water pipe, we got 2 points on the pipe from before, either that one or that one. Use either, choice is yours. I used the first one. And we also know from the first part that it's somewhere along that pipe, and we know the direction of the pipe is 230 because we worked that out in part A. So somewhere there is a point on that. That's a point somewhere on the pipe, and that's got to be joined up to this point minus 210. So if we think we'll draw a line, there's the pipe. There's a point somewhere on the pipe, minus 1 plus 2 lambda, minus 1 plus 3 lambda, minus 3. Here is our road. Here's the point on the road, and that point on the road is minus 1, minus 2, 0. They've got to be joined up at right angles to each other. So we know that means that when we dot the direction parts together, they're going to be equal to 0. So we need this, basically this line here, for want of a better word, the direction that's going in. Well, the direction that's going in, if we stick in an imaginary origin, let's stick the imaginary origin in there for the sake of argument, and let's call that's point C. Let's call that the point on the line, which is W. So C to W is going to be O to W minus O to C. O to W is minus 1 plus 2 lambda, minus 1 plus 3 lambda, minus 3. Take away O to C, which is that point, minus 1, minus 2, 0. That's going to be equal to 2 lambda, 3 lambda plus 1, minus 3. So that's that vector, and when we dot that vector with the direction part of the line, it has to be equal to 0 because at right angles. So when we dot 2 lambda, 3 lambda plus 1, minus 3 with the direction of the line 2, 3, 0, that's got to be equal to 0. And then we can solve that equation. 4 lambda plus 3 lots of 3 lambda plus 1 plus 0 is equal to 0. So that's 9, 13 lambda plus 3 is equal to 0. So lambda is equal to minus 3/13. Now that we know that lambda is minus 3/13, we can put our minus 3/13 back in here to find what the actual vector CW really is. CW is minus 6/13, minus 3/13 times 3 plus 1, which is 4/13, and minus 3. And then we can find the length of that vector by doing Pythagoras. And we can work out from that the length is the square root of 121 over 13. The question says find to the nearest centimetre. So to the nearest centimetre, that's going to be 3.05 meters. Job done.